Hello, so in this video we're going to be talking through the first week's asynchronous hours, which was that quiz that I set you on Theme 1 Algebra. Now, we're going to go through all the questions and I'm going to show you how you should have answered them. Just be aware that the quiz may have shown you the questions in a slightly different order, so they may not have come up in this exact order, but I think it should be enough for you to be able to work out what's what. Okay, so let's have a look at the first question. The first question which came up on my screen was to simplify this big long expression involving i's and j's. Now, the trick here was to realise that we are looking for terms which are alike. In fact, we call them like terms. Now, what is a like term? Well, a like term are terms that have the same variables in. Now, you just need to be careful with that definition, because just because a term has an I in does not necessarily make it alike to all of the other terms that have got an I in. For example, have a look at the first term. That is 3i squared. Now, if you notice, there's another term here right next to it that has also got an I in, but it's also got a j. These wouldn't be alike. Okay, I'm looking for like terms. In other words, a term which is alike to the 3i squared must have I squared in and only I squared. For example, 6i squared would be alike to it. Okay, I don't care about the coefficients, I don't care about the numbers, I just care about the variables that are involved. So actually, just to make it a little bit clearer, I'm going to write this question out again. So I have 3i squared minus 2ij plus 6i squared minus j plus 14j minus 8j squared plus 4i. Okay, so what I'm going to do is I'm going to go through and I'm going to find all the like terms. So we've already found one pair. We found 3i squared and we found the 6i squared. There's no other terms in this expression which have got I squareds in. So in that case, I think, okay, 3i squared plus 6i squared, that's going to give me 9i squared. That's it, I'm done with the I squareds. Now I'll just move along to the next term. So let's have a look at the term with the I and the j in. Well, if you have a look, nowhere else in this expression do I have a term with I and j in, okay? So therefore, there is only a negative 2ij. That's the only one of its kind. Okay, let's move along to the next term then, which is going to be the term with a j in. Let's have a look. Well, if you have a look, there's a term right next to it, which is 14j, which would be alike, because there's just j's in that term, okay? So negative j plus 14j, that's going to give me 13j. All right, great. Let's have a look at the last ones then. So I've got a negative 8j squared. Well, I've got no other j squareds terms, so I'm just going to write that in. So negative 8j squared on its own. And likewise, there's no other terms with just an I in apart from that 4i. So I'll just write that as plus 4i there. Okay, so that would be my final answer. I just have 9i squared minus 2ij plus 13j minus 8j squared plus 4i would be my answer there. All right, so let's have a look at my question 2 then, as it appeared on my screen. We have to expand 2 lots of z squared minus 3. Okay, so this is really a case of just expanding out brackets. So there's a few different ways that you can, or a few different techniques that you can employ here. The technique which I like is to think, this 2 has to be distributed over every term inside the brackets. In fact, we call this in algebra the distributive law, okay? And how do I distribute it? Well, I literally just multiply. So let's have a think. If I take the 2 and I multiply it by z squared, I'm just going to write that as 2z squared. And likewise, if I take the 2 and I multiply it by negative 3, that's going to give me negative 6. So asking to expand that, the final answer would be 2z squared minus 6. All right, so similar to the last question then, we've now been asked to expand a bracket with 3 terms in. So we've got negative 3 as the factor on the outside, and then we've got z squared minus 4z plus 3 inside the brackets, okay? So similar kind of thing, I've just got to make sure that the negative 3 gets distributed over every single term inside the brackets. So let's have a look. So negative 3 times by z squared will give me negative 3z squared. Then negative 3 times negative 4z, be careful there, because that's a negative times a negative, which makes a positive. And then I have 3 times 4z, that's going to give me 12z. And then finally, I've got negative 3 times positive 3, that's going to give me negative 9. So that would be my final answer there. Okay, so the next question then, I've been asked to simplify this expression. So I have 3 lots of f minus 2 minus 4 lots of negative f plus 2. Now, simplify is quite a common word in mathematics. And in fact, because it comes up so commonly, it's very difficult to know exactly what it means because it can mean lots of different things depending on the situation you're looking at. In this context, I want you to take the word simplify to mean express this thing in as fewer terms as possible. So at the moment we've got like a 3 and then a bracket and then a negative, then a 4, then another bracket. I want to express this in maybe 2 or 3 terms maximum. Okay. So let's first of all start by expanding each bracket out. So let's do the first bracket. I have 3 distributed over the f and the negative 2. So I'll write that over the right hand side. So 3 times f is just 3f, and 3 times negative 2 is negative 6. And then if I do the same on the right hand side, I have negative 4 times by negative f plus 2. So I just need to be careful here with my negatives, that's all. So negative 4 times by negative f is going to make positive 4f. And then likewise, negative 4 times by positive 2 is going to give me minus 8. Now this is already looking simpler in the sense that there are fewer brackets. In fact, there's no brackets on the right hand side there. So all I need to do now is just collect together my like terms, similar to what I was doing in the first example. So if I have 3f plus 4f, that's going to give me 7f. Then if I have negative 6 minus 8, that's going to give me minus 14. I think that is probably what I'm looking for there. That is probably as simple as I can go. If you like, you could try and factorise this. For example, I can see a common factor of 7 in both of these terms. So you could leave it as 7, lots of f minus 2 if you wanted. But I'm going to put a box around both of those things because either of them is fine as a final answer. Alright, so this one here I've been asked to expand, but this time I've been asked to expand 2 sets of brackets. So I have x plus 7 as one set of brackets and x minus 4 as another set of brackets. Okay, so similar kind of thing as before, I need to make sure that everything in the first bracket gets distributed over every term in the second. So if I take this x and I distribute it over both of these terms, I'm going to get x times x, which is x squared, and I'm going to get x times negative 4, which is negative 4x. Then I just need to go back and just make sure I distribute the 7, the second term in my first bracket, over everything in the second. So 7 times x, that's going to give me positive 7x. And then 7 times negative 4 is going to give me negative 28. So a good way to think about this is to make sure that everything in the first bracket meets up with everything in the second bracket. It's a bit like going to visit somebody's house, right? It's rude if you don't visit everybody, okay? So because x and 7 are a pair, they don't need to meet up because they're already together. But they do need to meet up with both the x and the negative 4. Okay, and you can see here that every term is met up with every other term that is not a pair. Okay, now all I can do is just collect together the like terms on the right hand side. So I've got x squared, and if you have a look, I've got negative 4x plus 7x. That's going to give me positive 3x and then minus 28. So that's how I would want my final answer to be left there. Okay, so similar example to the last one, but this time we've got 3 sets of brackets. So what I would encourage you to do here is actually just think about 2 sets of brackets at a time. Don't overload yourself. We've just seen how to multiply out 2 sets of brackets at a time, so let's do it. So basically, I'm going to ignore the x minus 7 for the time being and just pretend that we have x squared minus 6 times by x minus 1. But obviously I can't just ignore it, so all I'm going to do is just put the x minus 7 at the start instead, and then I'm just going to write this big set of brackets to basically represent the 2 brackets which I'm going to focus my attention on. Okay, so let's make sure the x squared gets distributed over everything in the second bracket first. So we've got x squared times x, that's going to give me x cubed, and x squared take away 1, that's going to give me minus x squared. Okay, then let's go back and make sure the negative 6 gets distributed over everything in the second bracket. So I have negative 6 times x, that's going to give me minus 6x, and then negative 6 times negative 1, that's going to give me positive 6. Remember, a negative times a negative makes a positive. So that's it. That's the second set of brackets, or the second 2 pairs of brackets dealt with, expanded out. Now I just need to go back and look at the x minus 7 and make sure that gets distributed over everything in this set of brackets now. Okay. So let's go forth. So we've got x, and that needs to meet up with everything in that second set of brackets. Okay, so there's 4 things it gets distributed over. So let's do it. X times x cubed, that gives me x to the power 4. X times negative x squared, that gives me negative x to the power of 3. X times negative 6x, that's going to give me negative 6x squared. And x times positive 6, that's going to give me positive 6x. Not quite finished, but I am halfway through. If I now go back and make sure the negative 7 gets distributed over everything in the second brackets, so there's 4 things again to distribute over, we can do that. And I'm just going to write it on the bottom line just to make it a little bit clearer. So negative 7 times x cubed, that's going to give me negative 7x cubed. Negative 7 times a negative x squared, that's going to give me positive 7x squared. Remember, a negative times a negative there. Negative 7 times negative 6x, that's going to give me positive 42x. And then negative 7 times positive 6, that's going to give me negative 42. So now all I need to do is go back and collect together all my like terms. Now handily, the way that I've written it, all the like terms are in columns, so it should be relatively straightforward. So x to the power 4 is just on its own. Then I've got a negative x cubed and a negative 7x squared term, negative 7x cubed term. That's going to give me negative 8x cubed. Then I have negative 6x squared plus 7x squared. That's just going to give me a 1x squared, or just x squared. Then I have 6x plus 42x, that's going to give me 48x. Then I've just got negative 42 at the end. So that should be the final answer there after I've done all of my simplification. Okay, so next question then, I've been asked to factorise. Now remember, factorising is the reverse of expanding, okay? So it literally says, okay, I've got 3x plus 6. Can you find me a common factor of these two terms, the 3x term and the 6? First of all, look for your numbers. So I think here, a 3 is a factor of both of those terms. So I'm going to pop a 3 as a factor on the outside. Have a look. Are there any letters which are factors of both terms? No, I don't think there are. So I'm just going to pop my brackets in, and I'm going to put my plus down the middle. Now I just need to think about expanding and make sure I get the thing on the left-hand side. So if I take this 3 and distribute it over my brackets, I'm basically saying, in the first instance, 3 times something has to give me 3x. Well, the only thing that can go there has got to be x. And then I say, okay, 3 times something has got to give me 6. Well, again, the only thing that can go there must be 2. So I think my final answer will be 3 lots of x plus 2. Okay, so another factorising example here, a little bit trickier than the last one, but I think we can manage it. So let me just write it out a little bit bigger. We've got 3 terms. We've got 15a cubed b squared c plus 5a squared b cubed c to the power 4 plus 30 a to the 4, b to the 5 and c to the 6. So just go through it methodically when you've got big things to factorise like this. It's exactly the same as the last example we were doing, there's just more things going on, that's the only difference. So first things first, I'm going to look for the numbers. So I'm going to ignore all the A's, B's and C's. I'm just going to look at the 15, I'm going to look at the 5 and I'm going to look at the 30. So can I think of a factor which is common to all of them? And I want the highest factor ideally. Well, 5. 5 works, doesn't it? So if I put a 5 as a factor on the outside of my bracket, that would definitely work. Now I just go through the letters methodically. So I'm going to look at the A's first. So I've got a cubed, I've got a squared, and I've got a to the power 4. Now what's the highest common factor of those three things? Well, an a cubed is like a times a times a, an a squared is an a times a, and an a to the power 4 is a times a times a times a. So in every single term, I'm doing a minimum of a times a. Hopefully that makes sense. So effectively what I'm looking for is the lowest power. That would kind of be my highest common factor. Okay, that's the way I think of it anyway. So in that case, a times a, which is a squared, is my highest common factor of the a's. Do the same for the b's then. So b squared, b cubed, and b to the power 5. In every single term, I have a b squared. I'm doing b times b in every single one of those things. So b squared would be the highest common factor of the b's. Then finally, just looking at the c's, I've got c here, c to the power 4 and c to the power 6. Well, in every single term, I've got a c, okay? So that's the highest common factor of all of the terms, of all the c terms at least. So I'm just going to pop a c on the outside. So that would be my highest common factor. Now I just go back and I put a plus and another plus to represent the separators between my three terms. And then I just literally go back and expand out. So if I have a look by taking 5a squared times by b squared times c, and I times it by something, it's got to give me 15a cubed b squared c. Effectively, I've just got to fill in the blanks here. Well, 5 times 3 is going to give me 15, so I've got to put a 3 here. And then a squared times a is going to give me a cubed. B squared times nothing, well 1 effectively, is going to give me b squared. And c times 1, that's just going to give me c. So that's fine for the first term. So now if I do the same for the second term, I've got to take that thing outside the brackets, multiply it with something, and it's got to give me that. Okay, so let's figure it out. Well, 5 times 1 is just going to give me 5, so I don't need to write a number there. Then a squared times 1 is just going to give me a squared, so again, don't need to worry about the a's. B squared times b is going to give me b cubed, and c times by c cubed is going to give me c to the power 4. Okay, so that would be my second term in my brackets. Again, taking the thing outside the brackets, multiply it by something, it's going to give me my last answer. So 5 times what gives me 30? Well, that's going to be 6. A squared times a squared is going to give me a to the 4. B squared times b cubed is going to give me b to the power 5. And then finally, c times by c to the 5 is going to give me c to the power 6. So that would be my final answer. But you can see, hopefully, how methodical I'm going through and doing that. It's no different to the example we just did. There's just more stuff going on. That's the only difference. Okay, so now we're moving into algebraic fractions. So I have 8 over 4 plus b over 5, and I need to simplify that. Now, again, we see that word simplify coming up. Here, the simplification means something a little bit different to what we were looking at when we were saying simplifying before. So I think in this case, when we're asking to simplify this, instead of writing it as 2 separate fractions, we just want to combine it and write it as one big fraction. Okay, so first of all, think about how you add 2 fractions together. I need the same denominator. So have a look, I've got 4 on one denominator, 5 on the other. A common denominator would be 20. So I'm going to try and write this as over 20, if I can. Okay, so the first fraction was a over 4. I've now converted it to something over 20. Well, I've had to multiply both numerator and denominator by 5 there. So the denominator becomes 20, the numerator gets multiplied by 5 as well to become 5a. Similarly, with the second fraction, I've had to multiply it by 4 to get 20 on the denominator. So therefore, I've also got to multiply the numerator by 4, so that's going to give me 4b. Now it should just be a simple case of, right, 5a over 20 plus 4b over 20, that's just going to give me 5a plus 4b all over 20. Remember, when you add fractions together, the denominator stays the same. I think this is what they mean by simplify here. Now, this is kind of what I mean. Simplification, if it asks to simplify, it can be a bit ambiguous because it's like, what does it actually mean? What's it actually asking for? I think in this case it says put it in a different form to what you got given it in, so rather 2 separate fractions, one big fraction. Whether that actually looks simpler than what we started with, that's debatable, okay? Okay, so another algebraic fraction question this time, but this time we have a variable on the denominator rather than just a number. So okay, we have y over y minus 2, subtract y over y minus 3. I need a common denominator. So the easiest way to get a common denominator, just multiply the 2 denominators together, okay? So in other words, I'm going for y minus 2 times y minus 3 on the denominator of both of these fractions. Okay, so let me just write that in for you. And then just think, well, what have I multiplied this first fraction by in order to get a denominator of y minus 2, y minus 3? Well, I've multiplied both numerator and denominator by y minus 3. So let me write that in for you. So I had y, and I've now multiplied that with y minus 3. On the second fraction, I had y, and I've multiplied by y minus 2 to get y minus 2, y minus 3 on the denominator. So I'm going to put y minus 2 on the numerator as well. Now I can write this as one big fraction. Okay, so I have y, lots of y minus 3, subtract y lots of y minus 2, and on the denominator I have y minus 2, y minus 3 like that. Okay. Now all I'm going to do is actually just expand the numerator out here. So I'm literally just going to go y times by y minus 3. That's going to give me y squared minus 3y. Then be careful here because I've got negative y times by y minus 2 on the numerator. That's going to give me negative y squared. Then negative y times negative 2 is going to give me positive 2y. And then I've still got y minus 2, y minus 3. And then all that's left to do is just simplify, collect together the like terms. So I end up with y squared take away y squared. Pff, gone, eliminated, cancelled, whatever you want. Negative 3y plus 2y, that's going to give me negative y here. So I'm going to have negative y over y minus 2, y minus 3. If you wanted to, you could also expand out that denominator, but just because I'm being lazy today, I'm just going to leave that as is. That's going to be the final answer there. Okay, so we've got a solving question next. So 6x plus 4 equals 16. That's nice and easy. It's just a game of opposites. So have a look. When it says solve, find me the thing which you don't know. That's always what I want you to think. Solve this equation means find me the thing you don't know. In other words, find me the letter in this equation. So I want to isolate x on its own. Now you could probably do this with trial and error. You could think, a number times 6 plus 4 equals 16. What I'm going to do though is I am going to reverse this equation. So I want to get rid of the plus 4 from the left-hand side. So the way that I can do that is literally by subtracting 4 from both sides of the equation. So on the left-hand side, I'm just left with 6x, because of course 4 take away 4 is just 0. And then 16 take away 4, that's going to give me 12. And then all I need to do to get rid of the 6, which is being times by the x, is divide both sides by 6. Okay? So I'm just going to be left with x on the left-hand side, and the right-hand side, 12 divided by 6, that's going to give me 2. So x equals 2, that's going to be my answer there. And you can quickly just check that. Well, if I stick that into my original equation, 6 times 2, because I know that's x now, 6 times 2 is 12, plus 4, that's 16. Good. All right, so I've been asked to solve this equation now. So I've got c multiplied by c minus 4 equals c squared plus 12. Okay, first thing I'm going to do here is I'm going to break down those barriers. I'm going to get rid of that bracket, okay? So I can expand out. So c times c is going to give me c squared, and c times negative 4 is going to give me negative 4c, and I'll just leave the right-hand side alone. Next, I want to get all the c's on the same side. So what I'm actually going to do here is take away c squared from both sides. I'm going to get rid of the c squared from this side and chuck it on the other side, okay? Well, if you notice, c squared take away c squared is just going to give me 0. So I'll just end up with 4c, or negative 4c on the left, and c squared take away c squared, that's 0, just going to give me 12 on this side. Now, if I want to just get c on its own, what I need to do here is divide by negative 4. So if I divide both sides by negative 4, let's see what I get. We'll just c on the left-hand side, and 12 divided by negative 4, ignore the negative for the time being, just think about 12 divided by 4, that's going to give me 3, right? So then I have a positive divided by a negative, that's going to give me negative. So the final answer should be negative 3 there. Okay, so my final question then is a solving equation again, so I still need to find x, but this has got some algebraic fractions in, but I think it's still manageable. Okay, so first things first, what I'm going to do is get all of the x's on the same side of the equation. So you see here, there's a term on the right-hand side mixed with a 3, which has got x in, so I'm just going to plus that fraction onto both sides. So I'll end up with x minus 2 over 3 plus x plus 1 over 5 is equal to 3. Okay, literally all I've just done is I've just added that fraction to both sides. Okay, good. Now I can combine this together as one big fraction. Well, this is very similar to what we were doing on above. So 3 and 5 are the two denominators at the moment. Make it a common denominator. I'm going to make it over 15. So this is going to be over 15, and this is going to be over 15. And I'm just going to leave the right-hand side alone there. All right, so what have I done to the numerator of the first fraction? Well, I've multiplied it with 5. So I've got 5 lots of x minus 2 as the numerator. Second fraction, well, I've just multiplied by 3 there. So I'm going to write 3 lots of x plus 1. Okay, now I'm here. What I really want to do is get rid of the fractions if at all possible. So first of all, I'm going to write it as one big fraction. So I've got 5 lots of x minus 2 plus 3 lots of x plus 1 all over 15 is equal to 3. So let's get rid of that denominator now, and I'm just going to do that by multiplying both sides by 15, because effectively I'm saying take the entire left-hand side, that 5 lots of x minus 2 plus 3 lots of x plus 1, I'm going to divide all of that by 15, and it equals 3. So in order to get rid of the divide by 15, just times both sides by 15 there. So I've got 5 lots of x minus 2 plus 3 lots of x plus 1 on the left-hand side, and then 3 times 15, that's going to give me 45. Okay, now I think this looks a little bit easier to work with. It looks very similar to the last example we've been looking at. So I'm just going to multiply this, this left-hand side out. So I've got 5x minus 10 plus 3x plus 3 equals 45. I'm going to collect together the like terms on the left-hand side. So 5x plus 3x is 8x, and negative 10 plus 3 is negative 7 is equal to 45. Now this is exactly the same as the example that we had maybe a couple of questions ago. So first things first, I'm going to add 7 to both sides of this equation here. So I'm going to end up with 8x on this side, 45 plus 7, that's going to give me 52 on this side. And then all I need to do is just have a look here and think, okay, I need to divide both sides by 8. So here I've got x, and then 52 over 8. I'm just going to write that as 52 over 8. Now, just because I think it's the last question and I just want to finish this off nicely, I am going to try and simplify that fraction down, okay? So 52 divided by 8, well, okay, they're both divisible by 4, first of all. So if I divide both 52 and 8 by 4, 52 divided by 8 is 13, and 8 divided by 4, that's going to give me 2. That's how I want to leave my final answer there. So 6.5 or 13 over 2 is fine, but those are all the questions done, so hopefully that makes sense.